When the air water button is depressed and little or no water is emitted from the air water nozzle at the distal end of the scope, it is time to replace the air water nozzle. First, locate the air water nozzle. It is the bent metal stainless steel tube which points towards the image guide lens or the video CCD lens. Using your X-Acto blade knife, carefully locate the opening hole which allows access to a metal set screw. Once the hole is located, usually parallel diagonally to the air water nozzle, carefully remove the black RTV. This allows access to the set screw. Using your number 1 screwdriver, unscrew the set screw counterclockwise to release the air water nozzle from the distal end. Using your number 1 screwdriver, carefully pry out the air water nozzle from the distal end. Using your X-Acto knife, carefully clean out existing black RTV from the air water nozzle hole. Using a very small gauge wire, carefully pass wire through hole, cleaning out debris that may exist inside air water nozzle hole. Again, be very careful, do not puncture air water channel. Bring the connector of the endoscope near the body section. Using compressed air, approximately 200 psi, no higher, put your compressed air hose onto the air water port of connector. While putting finger over air water bottle, carefully add air to endoscope. It will be necessary to hold down air water button, which will pass air through the entire scope, blowing out any debris from air water channel. It may be necessary to ask a second person to hold down air water button. This should clear out air water channel. We will now replace blocked or broken air water nozzle with a new air water nozzle, either for 100 series gastroscope or 100 series colonoscope. In this case, we are repairing a 100 series gastroscope. Using your RTV black, squirt a small amount of black RTV onto thin gauge wire. Holding a new air water nozzle, apply bead of black RTV near base of air water nozzle, being careful not to let any RTV enter bottom of nozzle. Slide in the new air-water nozzle into opening, being sure that nozzle is pointing over image lens. Push lens down as to flush with image guide and distal tip. Once nozzle is flush with distal end, using number 1 screwdriver, tighten, set screw to nozzle, hand tight, again making sure that nozzle is pointing over image lens. Using your fine wire needle, black RTV, apply a small amount around sides and rear base of air-water nozzle. Be very careful not to let any black RTV enter through nozzle tip. Also use the remainder of black RTV to cover set screw hole. Be sure to fill hole entirely with black RTV. Be sure to let black RTV dry for at least 1 hour before testing air-water function. This glue must be dry in order to pass through cleaning and sterilization units. Once you are sure the RTV is dry, hook up the endoscope to a light source, hook up the air-water bottle, and test to make sure that you have the proper air and water. Put your finger over the air-water button, which is the blue valve. Hold your finger over and be sure that you're getting sufficient airflow. Proper airflow for Olympus endoscopes is 90 cc's of air in 5 seconds. Test the water function by depressing the air-water valve down. Be sure you're getting proper water flow out of the nozzle across the image window. Olympus water should be 30 cc's of water in 30 seconds. When the endoscope knobs are turned up, down, left, right, and the distal end does not move each time these knobs are turned, it is time to adjust the play and the angulation. Using a dull pair of tweezers and some alcohol, apply alcohol to the end of the tweezers and very, very carefully slide dull tweezers underneath Olympus boot or cone. Apply alcohol around the entire diameter of endoscope. Carefully twist off boot cone from body section. Pull down cone to approximately 80 centimeters on the scope. If the cone or boot is very difficult to remove by hand, it may be necessary to use a pair of pliers with a soft rubber padding as not to scratch the boot cone. It may have to be removed in this fashion, again if it is too tight. Once the boot is loosened, again pull it down the insertion tube approximately 80 centimeters. Unscrew and pull down the first body section ring. Pull this piece down, which includes O-ring, to the 80 centimeter mark on the insertion tube. Using your C-wrench tool, slide tool up and over insertion tube onto body section. With the tool, feel for the two indentation marks in the body section ring and unscrew counterclockwise. This will unscrew ring, enable to pull down the body control cover. Using a pair of heavy-duty tweezers, unscrew the biopsy port retaining ring. Note, if it's a 130 series, it will be a black O-ring cap. Carefully take your tweezers and slide it down underneath black O-ring cap and carefully pry up and around. Once ring is removed, again take your tweezers and remove the biopsy port locking key, which has a small indentation to fit in tweezers to be able to pull out and remove. Again, using your tweezers, turn the biopsy port itself counterclockwise 90 degrees. This moves the notch from where the key was to the 3 o'clock mark. Once it is at the 3 o'clock mark, we can pull out the biopsy port. Reason being is two notches, once turned at 90 degrees, locks this biopsy port in place, making a seal with the O-ring. Once the retaining ring and biopsy port has been removed, we can now pull down the control body section. Carefully grasp the control body section midway, pulling down towards insertion tube. Be extremely careful when removing the body cover as not to pinch the light bundle and or video cable or image guide bundle underneath. This will cause permanent and serious damage. We have now exposed the angulation control assembly for adjustment. Now that we expose the angulation control assembly, we can now dismantle it to adjust the playing cables and the angles to manufacturer's angle specifications. First, remove 2 Phillips screws from rail assemblies. These are usually the 2 Phillips screws which has red Loctite on top of each screw head. Be sure to retain all parts removed from body section for reassembly. Unscrew 2 Phillips screws which hold down angulation control block. There is 1 screw on top and 1 on the underneath side. Carefully turn over the instrument. This is the most critical part concerning this repair, as not to damage light bundles and or image bundle or video cable. Carefully locate the Phillips screw on the underside of the control block by pushing away, if necessary, air-water channels, unscrewing the Phillips screw. Also on this side, it may be necessary to push very carefully aside biopsy channel and remove that Phillips screw. Turn the instrument back over. Remove the angulation control blocks by prying them diagonally out and away from the body section to approximately a 45-degree angle. The angulation control blocks simply slide out. Remove the angulation control guides with your tweezers. There are 4 of these, 1 each for the up-down, left-right cable. Be careful not to misplace or lose these small copper ferrule tubings. Now we have access to the angulation control cables themselves and the chain guide assemblies. This is the chain guide assembly which attaches to the knobs internally. These are the angulation control cables which run through coil pipes down to the distal end. we'll carefully remove the angulation control cables from the chain guides by sliding the chain guides up and over the control stoppers. Do this for each up, down, and left-right cables. Always be aware of the light bundles and image bundles as you're working on the endoscope. Please be sure to keep each specific cable in their holder. Once all 4 cables have been removed from each chain guide, slide down the control block ferrule to the beginning of each coil pipe for each up, down, and left-right cable. Each control stopper cable must match up to the notch in the chain guide block. When the cable has play in it, usually the end of the control stopper is 4 to 5 millimeters away from the middle of the angulation chain guide block. This drawing represents the angulation wire and control stopper in conjunction with the angulation chain guide assembly block, whereas this is the notch and the control stopper end should match up to the notch to achieve proper play adjustment in the cable. We shall now resolder angulation stopper to meet exactly the control block notch. First step in adjusting angulation cables in play is to be sure that all knobs, both up, down, and left, right, are straight, whereas in the arrows are pointing straight towards the eyepiece or video control head assembly. Also be sure that the lock knobs are in their free position. Also be sure that the insertion tube and distal end are perfectly straight. If it is bent to one side during angulation adjustment, this will cause improper angulation and play in cables. Again, be sure to straight along your working area. After you are sure that the knobs are straight and the distal end and insertion tube are straight along your working area, take your 2 number 2 screwdrivers, put them behind the head of each control block chain assembly. The 2 screwdrivers should be exactly across from each other, pulling down the chain for proper play adjustment. Do this for both the up, down, and the left, right. If one of these blocks is off or misadjusted, it will cause problems during your angulation and play adjustments. Again, be sure that these blocks meet. You can view the blocks easier here, directly across from each other. Again, be sure that they are straight across from each other, the two screwdrivers and the notches. With this particular instrument and the play and cables, we have come to the conclusion that the cable needs to be adjusted approximately 2 millimeters, meaning the edge of the control stopper meeting the notch in the chain guide block. You will need to solder the control stopper down, sliding it down and tinning the angulation wire approximately 2 millimeters. We will now proceed to unsolder the control stopper and move it down approximately 2 millimeters. Using a toothpick and some tissue, we will carefully cover the endoscope control assembly, sliding down a toothpick underneath the wire as to not let soldering flux splash onto the control body section while soldering. Using another toothpick and solder flux, we need to cover the entire control stopper with flux. Again, making sure that the entire control stopper is covered with the flux. Also, I will apply solder flux 2 to 3 millimeters down the angulation wire, which needs to be tinned with flux in order for this control stopper to properly hold onto this cable without breaking off during use. Using a quality soldering iron and a small amount of flux and a small amount of solder, we will heat up the end of the control stopper, sliding it down approximately 2 millimeters from the end of the wire to the top of the control stopper. Using more flux, heat up the stopper as to allow the solder to flow through the control stopper to the end. This allows solder to flow again through the control stopper and to tin the angulation wire. Be sure that solder has flown throughout the entire control stopper to the end of the control stopper. You will see silver solder out and tinned into the stainless steel angulation wire. If the solder is not flown out the back, the stopper will fall off during use, which in turn will cause complications during procedure. It is very critical that the solder is tinned to the wire and out the back of the control stopper. Before we actually cut the cable, we must be sure that the angulation chain guide blocks are directly across from each other. Using two number 2 screwdrivers, grasp the back of the angulation chain guide blocks and be sure that both screwdrivers are directly across from each other. As long as the end of the control stopper is now matching the notch in the control block chain guide, we can proceed to cut the play in the cable, which was in this case 2 millimeters. We will make a cut with sharp tweezers exactly against the head of the control stopper. Now that we are sure that the control stopper meets the notch in the chain guide block and both blocks are straight across from each other, angulation knobs are straight, and tubing and distal end, we can cut the XX cable off. Using your sharp needle nose pliers, cut off excess wire. You will do this for all 4 wires, both the up, down, and left, right cables. Once all 4 cables have been cut and soldered, clean up any excess solder flux that may have splattered onto body section, as it will stop any corrosion that the flux might cause, using toothpick, tissue paper, and acetone. Place angulation wire back into chain guide control blocks by pulling back up copper ferrules onto control stoppers. Pulling out the chain guide blocks. And reinserting wires into chain block. It can be difficult at first reinserting angulation wire ferrules back into chain guide blocks. If necessary, it may be necessary to adjust the cable by using the up, down, left, right knobs to allow for a certain degree of slack in order to fit stopper back into block. Also be certain that the coil pipes stay in their respective slots. %90 of the time Olympus coil pipes are color coded. Up is usually a red color. Left is green. Down is usually black, and right is a non-colored silver. Again, be sure that these stay in their respective slots. Once all wires and coil pipes are in place, we will now check for play before reassembly. When the knobs are turned, just barely, the tip should also deflect at the same time. If the knobs are turned and no deflection, you'll have to repeat procedures to adjust for play. It goes for both up, down, and left, right. Tip should deflect as soon as knobs are adjusted. We will first replace rails, being sure that they're clean and free of any debris. Also being sure that the copper piping is is in between rails. Rails have a slot and fit into receptacles inside the control body. Put them in at a 45-degree angle. Then slide them in and through rails without overlapping. Once the first two rails are in, adjust copper pipes to be flush. Using our Phillips head screwdriver, we'll take one of the longer Phillips head screws, sliding it through the top and through the copper ferrule tubes. It is extremely critical that these rails are not overlapping in any fashion to when you tighten this down, otherwise control chain guide blocks will not be able to move freely. Tighten down only hand tight. Use some Loctite on top of screw head. Again, for other two cables, once rails are straight and copper ferrules are in place, using Phillips and long stainless screw, slide screw down through rails and ferrules, again being sure that rails are in their proper slots and not overlapping in any fashion. This is a very dangerous situation, can cause the cables to lock up during procedure. Also, Loctite head of second screw. Next step is to insert the angulation block. First step is to loosen Phillips screw. Do not take it all the way out. We were just loosening this up. There are two posts at the end of angulation block. These fit in internally to the control body at a 45-degree angle. The two slots will meet the two holes inside body section. Once it is inserted in, push the block flush up against the body. Again, lining up block with holes internally, slide it in, pushing it flush up against the body. Using Phillips screwdriver and small Phillips screws, tighten down block into body. Turn over the instrument. Inserting the other two screws into block assembly Again, this is very critical as not to damage any of the light bundles or suction channel. Take screw and gently push, in this case suction channel side, screwing block into body. With this block, gently push away light bundle and air water channel to gain access to screw hole for other block. If there's any slide or pressure applied to any of these components, it could cause serious damage to the endoscope. It is very critical that you do not damage any of these components. Turn the endoscope back over and remove the angulation brackets from each block. The angulation cable adjustments are the 4 screws which we have just accessed by removing the covers. They can be adjusted either anti-clockwise or clockwise. Using your angulation control chart included with the video, we will now have to adjust the endoscope for proper manufacturer specification angulation. To adjust for proper angulation, consult Olympus operating manuals for proper angulation. In this case, GIF XQ20 Olympus gastroscope will need an angulation adjustment of 210 up angulation. This scope will require a 90-degree down angulation adjustment, and the left and right angulation will need to be adjusted to 100 degrees. To obtain these angulation adjustments for up, down, left, and right, it will be necessary again to turn these angulation control cams to meet the required manufacturer specification on angulation. The cam will be turned either clockwise or anti-clockwise. Moving the up, down, and left, right knobs to their fully extended position, you will adjust this cam again until it meets the required angulation. You can see as I move the cam here, it allows for the angulation knob to increase with each turn. Once you have met the proper angulation, then you will stop. Be sure the top of the cam notch is pointing up to allow for retaining bracket to slide back in. If you go too far with angulation adjustment, turn the cam in reverse, which will decrease the angulation. Always check it to your angulation chart and the Olympus manufacturer's specifications. Once all 4 cams are adjusted for the up, down, left, and right, we will now reinsert the control stoppers with the Phillips screws. We have now adjusted the play and the angulation and cables. Once we are sure angulation is set, again, clean out body section with acetone to clean up any residual flux that may have splattered onto the body section. Carefully pull up body cover. Using your toothbrush and G1 white lithium grease, go around outer O-ring to clean any debris to allow for proper seal. Push up body cover carefully onto control section. Slide up retaining ring into body control section housing. Using C-wrench tool, slide up and over to retaining ring, screwing body cover onto scope control section. Do not over tighten. Hand tight is sufficient. We'll now replace biopsy port assembly. First, we will take biopsy port, cleaning off O-ring with white lithium grease, which will allow for proper seal. Slide body housing at a 90-degree angle towards you with slot at 90 degrees. Then using tweezers, slide port to meet notch in body housing. Retain key for biopsy port, sliding it in to notch at top. Get the retaining ring using a small amount of black RTV. Put thin film threads of retaining ring. Slide up and over biopsy port onto body housing. Screw retaining ring clockwise onto biopsy port. Screw this ring down hand tight with tweezers. Next step is to pull up a small biopsy cover, clean O-ring with white lithium grease to make proper seal. Push up to fit underneath body cover. Slide second O-ring up and underneath small control section, clean with white lithium grease. Using a pair of dull tweezers, use some alcohol on the tips. Carefully slide underneath cone. Be sure not to perforate cone with tweezers. Apply a generous amount of alcohol, then slide cone up towards body section. Slide cone up, meeting O-ring, turning clockwise, back on to control section threads. Clean any grease or dirt that might have accumulated on insertion tube, only using tissue and alcohol or soap and water. Once angulation control adjustments are made, we'll need to airtight test the instrument with a handheld airtight tester, pumping up the endoscope and checking all body covers that we have just opened are not leaking at all, including the entire rest of the endoscope. If there are any leaks where we made the repairs and removed body covers, they will need to be removed again and pulled back up and resealed with white lithium grease. This is a critical part. Please again make sure that there are no bubbles, no leaks within the body covers which you have just replaced. If the flexible endoscope has holes or cuts or tears in the bending rubber sheath, it will need to be replaced. As long as you have all the materials you have just seen, we can now start with the removal and replacement of the bending rubber sheath. Start at the distal end. We shall remove the bending rubber glue joint at the distal tip of the scope first. Using a sharp X-Acto knife, we cut diagonally into the glue joint, being careful not to cut into the distal end hood assembly itself. Carefully cut into glue joint remove pieces of glue. It will be necessary to make several cuts with X-Acto knife. Remove all glue and binding thread from bending rubber sheath. This exposes bending section underneath glue. Using a good quality Dremel tool with a sanding bit, we will remove the remaining glue around the distal tip area. It is extremely important not to Dremel into the distal end itself. We are just removing the excess glue around the distal end hood or CC cover. Dremel all glue off around the whole diameter of the distal end CC cover. Again, be very careful not to cut into the CC distal end cover itself. If need be, you can use a small file with a fine grade to remove glue if you do not have a Dremel with a small sanding bit. File is slower, but it works just the same, and you decrease the risk of cutting in to the distal end hood. Moving down to the second binding glue job, we use a good quality Scotch tape wrapping around the base of the second glue joint, bringing the tape around 2 to 3 times. This will protect the insertion tube from cutting and nicks from dremeling or filing. For added protection, you can use ordinary paper towel by wrapping it around the insertion tube below the tape and the glue line. And taping this onto insertion tube. This will also protect insertion tube